Welcome to the another session. In this session, we will try to understand the TCP header, the brain behind transport layer TCP. So have you ever wondered how whatever data is sent from one application, how it will be received at the other exact application, whether your packets are arrived in the order or not, how the ordering of the package are maintained, if any packet is lost, how those will be resent, if there is a network congestion, how it will be managed, how to guarantee that whatever is sent is received, all these questions, right? Have you ever wondered? If you wondered about these questions, right, then the answer to all your question is TCP header. All these things till now, whatever we have seen, right? Checksum, then three-way handshake. How actually that will be carried out? So that is carried out with the help of TCP header. So TCP header is very important. So how does TCP header looks like? So for you, I have put a diagram here. This is how the TCP headers looks like. So before we see each part of this TCP header, let me tell you a big picture. The TCP header is a sequence of fields, right? It's a sequence of field, each with fixed and variable size packed tightly together, right? In the diagram you can see, and these are the bytes actually, okay? So 20 bytes and all. So everything is in terms of byte. Whatever block you are saying, right? It's also a byte. So at the end of the day, TCP header is of some bytes. Okay. So now let us try to understand the each packet and parcel of TCP. Okay. So initially, the very first thing which is there in this is source port. Okay, source port and destination ports. So what does this means? What is a source and what is a destination? We have seen, right? If it's a HTTP message, HTTP, the port is 80, correct? If it is the HTTPS, then port is 443. If it is email, port is 25. Whatever, right? So whatever application, whatever protocols and all, right, whatever application you are using, there will be port number. So there will be a source port, there is a destination port. So this will decide that who is the sender and where it should go, what is the destination, in simple terms. So basically in real life analogy, it will be a flat numbers, for example. Okay, flat numbers. Then next part is your sequence number. This is one of the powerful feature of TCP header. Okay, it tells the receiver the position of segment in the overall data stream. Okay, so if you are sending up packets in the data stream, right? Multiple packets you are sending. So what is the number of that packet in the stream, right? See, single packet doesn't make sense. If it's a bunch of packets, right? You are sending a file. So that file will be divided into the packets. So each packet will not make sense. But if you club the packets together, right, in sequence, then it will be a file, right? It can be transformed into a file, and that will make a sense, right, for the humans. So what makes that to assemble? That is a sequence number. So for that you need to assemble it in sequence, right? So that's how the sequence number helps here. So every packet will have a sequence number. It's like a page numbers in the book. Okay. If the pages come in random number, sequence number help them to sort, right? So that is how sequence number. Then next is acknowledgement number. Okay. So this is used by receiver. Receiver uses this to say I got everything until byte X. Please send me starting from X plus 1. We have seen this, right? So as soon as this is a sender, this is a receiver, right? So as soon as he received the packet, right? And again sender send another packet, but the receiver doesn't receive it, then it will send an acknowledgement saying that I have not yet received this first packet, I directly received the second packet, right? So this is an acknowledgement in the windowing algorithm of 3, right? We have seen this. So that is where the acknowledgement number comes handy. Okay, this helps that the reliability is maintained, and it helps to trigger the retransmission of the packets. So if I want to explain you quickly, so it will be like this. You have a sender, you have a receiver. So the windowing algorithm is 3, right? So 1, 2, 3 packet is sent. Then again 1, 2, 3. Then again 4, 5, 4, 5, and 6 is sent, right? 1 is received, 2 is received, 3 didn't receive, but 4 is received, right? So as soon as 4 is received, the receiver send the acknowledgement saying, I have not yet received 3, right? It is keep on sending the ACK flag, acknowledgement number, saying that I have not received 3. So before the expiration time only, then sender resend it. So that's how the acknowledgement number helps. Okay, it's like sending, I have received the parcel 10. Now I am waiting for parcel 11. Please send it. So it's similar like that. Okay. Then next is data offset. This will tell you that so every packet, data packet, right? It will have some instruction. It will have a instruction, okay, and it will have a actual data, right? So this data set will tell me that when my data will start. This is this is represented in the byte, right? So after what location my real data will start. That's how the data offset will decide. That will tell. Okay. Now next is reserved. Next is your reserved flag. Okay. Now why this reserved is kept? So it is also some of the bytes, right? Some bytes are reserved for future extension. So I have told you, right? We are whatever innovation we are saying that is happening because of the network, right? Initially we used to send a text messages, but now we can directly do video communication. We can do hell lot of things, right? Video streaming, live gaming. How this is happening? Because this network is evolving. So that's how some bits are kept as reserve for future innovation. Okay. Then we have some flags. These are the flags. So what are these flags? We have seen, right? Some of the flags we have seen, which are like SYN, sync flag, SYN, ACK. Okay. This sync is for starting communication. We have seen, right? If sender is sending to during the three-way handshake establishment, the sender send the sync message to the receiver, right? So that is the signal for starting communication. So ACK, that is the acknowledgement of data. Then there is another flag that is finish. That is the end of connection. FIN. Then RST, that is the reset connection immediately. Then PSH, that is push data to application quickly. Then URG, this is another flag, URG, urgent data inside, right? So these are some of the flags with their own meanings. Next is your window size. So this will help in congestion, to tackle the congestion over the network. So we have seen, right, the congestion window size will be set as 3 ideally. Okay, and accordingly based on your network congestion it will be increase exponentially or linearly, right? So that is what your window size. Then checksum, another field is your checksum. Checksum we have seen to maintain the integrity of the data. That is what checksum is used for. Whatever checksum is computed, right, it will go in this header. Then urgent pointer, you have a urgent pointer. So this is also used rarely. Okay, this shows where the urgent data ends. Okay, but it is rarely used. So for time being you can ignore it. Next is your options. Okay, now this option is important. In these options what are things we have is maximum segment size, MSS we have, then window scaling, timestamp. So all these are the options. Options are like a special instructions which you will give on the on this packet. Similar like what special instruction we will give, right? Behind this, nearby this landmark, all these are the special instructions. So all your special instructions will go into this option property. Okay. Then the final property is your data, the actual data which is going through this packet. It's a data chunk actually, right? So what the actual data which is going through this packet is represented here. So that is how your entire TCP header will be composed. And every data packet which is flowing through the network has the similar structure. Now, if we trace back to the problems and how those are getting solved, right? So, how does TCP ensure the order? Then it is ensured using sequence number, right? Sequence number. How does TCP know what is delivered? It is by acknowledgement number. How does TCP avoid overwhelming the receiver? It is with window size. How does TCP detect the corrupted data? It is with checksum. How does TCP starts and end connection? It is based on these flags, right? So every property solves some real time problem in the network. Okay, so that is all about the TCP header. If you like this video, do share, subscribe, and tell your friend about my channel. This will help me a lot. So stay tuned.